Hi everybody, I'm Jason Williams. We're all handed someone else's code from time to time, and what we need to do is leave that code a little better than what it was when we got it. What I'd like to do today is take a look at a small project I found on GitHub and make sure that we leave it a little better than when we found it. This is a very simple application. It's written by a developer that goes by D.A. Hafner, I believe is how you say that. They're from Switzerland, it looks like. And it is described as it's used for calculations about different RAID fault tolerances and usable storage space. So it does some calculations based around RAID arrays in hardware servers and whatnot. So what I've done is I've forked the code and I have pulled it up in Visual Studio. So let's go take a look at that. All right, so over here in Visual Studio, we can see we've got a single window and it has several inputs. It's got a button. It looks like these are probably the outputs here. The window has some code behind. It's doing some checking based on which of the RAID checkboxes or radio buttons are checked. And it's doing a calculation. And then as we go down to the bottom, we see that it is assigning some strings to some text blocks here to give us our output. There is no other code in this project except inside the main window, so it's a very simple project. And so let's run it and see what we have when it runs here. All right, so if I am understanding the project correctly, this is the number of disks. So if I say I want 3 disks and I want them all to be 2 terabytes and I want to create a RAID 5, we're going to do the calculation. And again, if I'm understanding correctly, we have 3.64 terabytes of usable space, and we can have one drive fail on us before we start to lose data in a RAID 5 configuration. If we change it to a RAID 0, then we have more space, but we have no failover. All right, so let's take a look at what we can do to make this code a little bit better. So one of the things that I always like to do is look at how we can make this testable so that when we do test it or when we do change it, we know that we haven't broken anything. So let's make ourselves a list of goals here. I think the very first goal should be to make it testable. If it's not already, we need to make sure that we can apply some unit tests at least to it. If it was a more complex system with back end, or if it was talking to a database or something, we may want to include some unit tests, or I'm sorry, some integration tests in that. But for now, I think we're just going to call this unit tests. I think the other thing that I'd like to do with this is make it so that it can support multiple languages. And so we're going to do some localization. And there's a couple different strategies we can use for that. Along the way, it's very possible that we may find that we want to take advantage of some of the niceties in WPF. Some things like binding and that sort of thing where we don't have to talk to controls directly. And so maybe we want to change to an MVVM pattern, maybe. If we do that, it may be a significant change. And for this, the size and scope of this particular project, that may just not be necessary. So we'll call that a maybe. But for sure, we want to make it testable. And then for sure, let's make the new feature we want to add to it localization. We want to make sure it supports multiple cultures. Okay, so let's jump into the code and see how we can make that happen. All right, so typically we would have the original developer try and describe this to us so we could do a code review. We're not in the position to do that, and so we've kind of reviewed it a little bit. But we do want to make sure that we don't break it when we change it so that it supports multiple languages. The best way to do that is to introduce some unit tests that test the functionality, and then we can be assured that the existing logic is not broken when we create a new feature. So the very first step would be to add a new test project. So let's go ahead and we'll pull up XUnit here. And we're going to call this storagecalc.tests. And I did look, it is a .NET 5 project, so we're going to go ahead and keep that. And then, of course, we're going to need a dependency on the existing project. All right, and so it's very small on your screen, but you may be able to tell that the dependency is, there's something broken. The problem is that the target framework is not the same between these two projects. And so if we go look at the project file here, this is a .NET 5.0 for Windows, while our test project is just .NET 5. .NET 5 cannot reference .NET 5 for Windows, so we need to change it to be the same target framework. So we'll do that. That will eliminate the dependency issue that we have there. And now let's just do a test build. Our very first test is always, will it compile? So let's see if it'll compile. And it did indeed compile. So let's go back to the original code. I think probably the first thing I want to do is try and write a test that runs this code that's inside of this click event handler. However, just from previous experience, I know it's very difficult to test a WPF form in a unit test. It's probably possible with some sort of other framework, but it is fairly difficult. There's also UI testing frameworks and that sort of thing out there as well. But just to do a simple unit test, I think what I'm going to do is go ahead and extract this as its own method. And so we'll refactor, and we're going to call this, we'll just call this calculate. And then if I wanted to pull this into its own class, you'll notice that it's referencing some of these controls directly. And so I need to eliminate the dependency that this method has on these controls, because when I do move it into its own class, it won't have access to these controls anymore. All right, so one of the things that is going to be helpful is if we have that class made, and we can use the compiler as sort of a guideline, some compiler errors as a guideline here. So let's go ahead and create a new folder. And with the idea in mind that maybe we're going to move to an MVVM pattern, I'm going to call this view models, just because if we do move in that direction, that's ultimately where we're going to be putting this type of code, because this code is going to be glued or bound to the WPF form, to the XAML form. So let's go ahead and create a new class here, and we'll call it calculator. No, let's go ahead. If we're going to go, let's go all the way. Let's call it main window view model. Okay, and then let's go back over to our code behind here. We'll copy this method, cut it out of there, paste it in here, and we'll make it a public method that can be accessed. And then we're going to have to create a reference to our new class. And call that. Okay, so that looks all good, except when we go over here, the controls are no longer available to us like we predicted, and so we're going to have to be passing that information in. Now, my current strategy with making this testable is that we leave it as much alone as possible, so meaning we do not want to change it any more than we absolutely have to. And so obviously there's some refactoring that's going to happen in the future to make this code a little bit better. However, that is not our goal right now. Our goal right now is just to make this testable. So to make it testable, the very first thing we need to do is turn these controls into arguments that can be passed in. And so we'll call this string discount and string disk space. Now, we may want to pass those in directly as doubles in the future, some sort of numeric type. But for this particular iteration, we're just going to keep them as strings. Okay, and so discount. So I'm going to cut that out of there, replace it with discount, and then cut that out of there, and replace it with disk space. Okay, and then obviously. Well, I've not named them correctly, so let's go ahead and rename them to something that's not going to interfere with existing variable names. That can be a trick sometimes. So, all right. And then we've got the radio buttons that need to be changed as well. And so we're going to call this rate 0, and we're going to turn that into a parameter, and then we're going to call this rate 1. We're going to turn that into a parameter. So now if we go look at what our arguments are for this function, we see that all of these have been, well, that one is actually misspelled. That's going to bother me, so I'm going to change that. All of these have been turned into Boolean parameters that can be passed in. So now we don't rely on those radio buttons directly. The text blocks that are getting set as a result are probably, there's a couple different ways you can handle it. You could use out parameters or something to that effect. That may be one way to go about it. You can also use a tuple. And so if we change this from a void function to string, and then these are named, what are these named here? Total size and fault tolerance. So total size and another string called fault tolerance. Okay, and then we can change this so that we're returning that and that. Okay, all right, we're a little bit closer. The message box, obviously, if you're familiar with the MVVM pattern, you certainly wouldn't want to create a message box or pop a message box directly from your view model. However, we're not into that pattern yet. We're just going to go ahead and do a using statement that will allow us to call a message box show from here. And then probably the last thing is that we're going to need to return. So all these branches in here, all these if statements, are going to need to return because they're exiting early in the case that there's an error. So if you selected RAID 1, it requires 2 disks. And if there are not 2 disks, then we're going to show an error and we're going to return and basically do nothing. In the short term, until we can refactor, is we're going to return defaults here. That way, we can make sure that all of our branching paths do indeed return a result. We're missing some returns down here in the catches, so we're catching these errors, so we're still expected to return a result. So we'll go ahead and do that. And now that we have all of that set up, I think this method is pretty complete. Let's go take a look at the calling code, which is in that window. Obviously, it's missing all of the parameters that we've added, so we're going to have to add those back in, or add them in. And so we're going to be returning a tuple, so we're going to need the total size and fault tolerance to be returned. And we're going to pass in the disk count text, the and then RAID 10 is checked. Okay. It is complaining here because is checked, if we look at it, is in fact a nullable Boolean. And so what we'll need to do, one thing I did forget to do is change these generated parameters to nullable bools. That way we can, because we don't know, maybe there was some sort of behavior in our code that when one of these is, one of those is checked properties was null, maybe there was some different behavior for it. So we just don't know that, so we want to keep it the same. And so now the only other thing left is to assign our outputs to our text boxes. And so we're going to say total size text equals total size. and fault tolerance equals fault tolerance. All right, so again, we're using our compiler as a test. Let's go ahead and run it, make sure that it still gives us somewhat of an expected result. So I believe before we did 3 disks, 2 terabytes each in a RAID 5, and 3.64 terabytes, and 1 disk can fail. So that appears to be correct. Everything seems to be functional. And so at this point, what I would probably do is I would go ahead and commit, and I would say moved main logic into its own class to begin testing. Okay, and so now we have the capability of testing just that one class. Our view model is what we called it. It's not technically a view model at this point, but let's go ahead and create a test suite for it. So main window view model tests, and we're going to go ahead and let it rename that. And then our system under test is going to be that view model. And so let's go ahead and create a main window view model as our system under test. And it's not very complicated, so we won't need a constructor. We'll just use some initialization code there. And then our very first test, I think, is probably going to need to just take a whole bunch of different parameters. We're probably not going to need a fact here. We're probably going to need a theory if you're familiar with XUnit at all. It's going to allow us to create some inline data here. And so I think our test that we had before was 3 disks, 2 terabytes each, and it was, that would be RAID 0, RAID 1, RAID 5 was true, RAID 6 and RAID 10 were both null. And then I'm trying to remember what the result was as far as the calculation goes. Let's go over to our view model. So when we have RAID 5, we can have this here. And so our fault tolerance is always going to be that in the case of a RAID 5. Let's do, so one of the things that when we're trying to make a system testable that wasn't testable before, really the only way to make sure that we test for the correct things is that we're going to have to do manual testing, just like I'm sure the original author of this project did. And so if I had 3 disks, 2 terabytes each, and RAID 5, 3.64 TB, space TB, 3.64 space TB is the expected result there. And so 3.64 TB would be the expected result. Okay, and then let's name our method, our test, to calculate returns expected strings when good data is passed. Okay, general test name, certainly not specific. This is going to take a lot of the same arguments as the original method, and so let's go ahead and copy those just for brevity's sake here. And then we're going to have expected total space and the expected fault tolerance. Okay. All right. So what I'm going to do is I'm going to say total space and fault tolerance equals our system under test, calculate, and then we're going to go ahead and pass in all of our parameters here, RAID 0, RAID 1, RAID 5, RAID 6, and RAID 10. And then we're going to do some assertions on what the expected results were. So the expected total space is tested against total space, and the expected fault tolerance, like so. Okay, so let's go ahead and run this test here. So let's go ahead and go look at our test and make sure that it passed, and it did indeed pass. And so as we add more inline data to this test, it will continue to test different portions of the code. So that brings up a good point. Let's go take a look at the code coverage. Really, for this particular type of refactoring to make something testable, the thing that we're going to be looking at is code coverage. That's going to be our guide. And so let's go ahead and analyze code coverage here in Visual Studio. When this comes up, I apologize that this is so small on your screen. The system that we're testing is 46.55% covered by this particular test. And so if we go into this class or this method, we can see all of the code that is highlighted in blue has been run, is covered by the tests, and all of the code that is in white is not covered. And so the idea is that we want to come in here and we want to find all of the code that is white, and we want to turn it blue. So to do that, for instance, we would need a test for RAID 0. And so if RAID 0 is true, then we would fall into this if statement here, and we would be testing that particular group of code. And so if we come in here and we say, all right, let's do a RAID 0 test. So we need to get our expected results first. And so we'll run the application. We're going to do a RAID 0. And let's say that we have 2 disks, and there are, just to be different, let's make them 4 terabytes apiece. And so with 2 disks at 4 terabytes apiece in RAID 0, 7.28 space TB. And then we have this word here. Unfortunately, I don't speak this language, and so I would assume this means 0 or none or something to that effect. So 7.28 is what we're looking for there. So let's go ahead and create a new test with that data in mind. And we had 7.28. And then this was, that word we think means none. We had 2 disks, and they were 4 terabytes apiece. So let's go into the code and find our fault tolerance word here. Yeah, they just hard-coded to this word. And so that is what our expected result would be for those inputs. Oops, not quite. Be very, very careful that you address all of the arguments that are being passed in. So this is a RAID 0, obviously. Okay, so we're going to go ahead and run that. I'll debug, and just in case we hit some sort of exception or something, we can see it. And again, it appears that all of the tests did indeed pass. And so we've got 2 working tests now. If we go back and we look at our code coverage, let's go in here into our method. Now we can see that the RAID 0 group of code is now under test. It's got a unit test that covers it. And so then we can move on to the next test, the next block of code that's white that we want to turn blue, and proceed further and further down until we get all blue code. Okay, so I'm going to go ahead and skip that, fast forward it for you a little bit. Okay, so we're back. We've got the happy path, if you will, happy path tests created. That is where no error occurs, so there's no pop-up in essence. And so we've got RAID 0, RAID 1, RAID 5, RAID 6, and RAID 10 all covered. They are all passing, so we can see all of our tests are passing there on the left. Now we get into something a little more interesting, and that is that this code is popping a message box whenever there is a problem, and that's not an especially great way of handling errors or user input problems, that sort of thing. However, that is the way the system is working currently. We want to be able to mock that message box. That way we don't have to click an OK button every time we want to run our tests. Okay, so how are we going to mock the message box class? The message box, if you go look at the definition, show is just a static method, so it's very difficult to mock a static method. So what we're probably going to need to do is create a wrapper for it. So the way that you would do that is, we'll call this a message box helper. And then we're going to create a new method called show. It's going to take a string because that's pretty much the extent of what we're using. And then this is going to be message box dot show message. Okay, and so that is going to be our message box helper. We could probably go as far as, in fact, it's probably a good idea since we're testing. We should probably make a message box helper interface, and that is going to look very much like this here. Okay. And then our viewModel class is going to need, let's get rid of the code coverage highlighting for now. It's going to need an instance of that injected into it. So main window viewModel. And then we're going to create an instance of the iMessage box helper. Okay, and then let's go ahead and now we can pass in the message box helper, and the way we're going to use it is we're going to replace everywhere we have message box with our injected instance. Okay. So now we don't have any reliance on system.windows anymore, which is nice. It solves some of that problem. And then we can inject this into our viewModel here. So over here, when we create an instance, just for brevity's sake, for now, we're going to say new message box helper, like so. Okay. So we're going to need to change our test class here just a little bit. And let's create a constructor here. And I'm going to go ahead and take a dependency on mock. So let's go ahead and grab a NuGet package. All right, so we got mock installed, or MOQ. And so now we're going to create a new mock. Message box mock. This new mock. If I could spell correctly there. And this is going to be of the iMessage box helper interface. Okay. And then we're going to say, let's store our mock object, iMessage box helper. Let's set that here. Okay, and then we can pass it in when we create the system under test here. All right, and then obviously we don't need our instantiation code there. If we create another theory, one of the use cases was if we had less than 2 disks, and it doesn't really matter how big they are, and it was a RAID 1, I believe it was, is one of the cases where we would throw a message box. Yeah, so RAID 1, where it's not 2 disks, we're going to get a message box. And so This would be true for RAID 1, RAID 5, and RAID 6 and RAID 10 would all be null. And then we would expect a message box to be thrown here. And so let's call our test calculate shows error message box when bad data is passed. And it's a general name for a test, I understand. But what we're going to do is we're going to say, we're going to copy these parameters from our other tests because I'm a lazy programmer, and paste those in there. And then what we're going to do is we're going to say the same thing So what we could do, because if we go look at the code that we're trying to test, if disk count is not 2, then a message box is shown. What gets returned is a default. And so we could say, we could assert that we're getting a default string for total space, and we're getting a default string for fault tolerance as well. And that would work. That is one way to go for sure. If we run this test, if I've done everything correctly, it should pass. Yep, and so we can see that our new test does indeed pass. So while that test does pass, we're not exactly testing everything, the full functionality, because the full functionality is that a message box pops up. So what we want to test is that our show method was called on our message box class, or message box helper class. And so the way we can do that is we can say, actually we can't do that right now because I didn't save the mock in the right place. So let's go do that. Let's make this a mock of I message box helper. And we'll call this message box mock. And there, now we can test it. So down here, okay, so if we wanted to test if our mock was actually called, what we would do is we would say the mock, let's see, what do I call it, message box mock, and then we're going to verify that our mock show method was called with any string. Okay, we don't particularly care about the string. You could also pass in if you were expecting a specific string in here. I'm not going to go that far. You could certainly verify that the specific string was passed in. And so we'll go ahead and make sure that the message box was called and our test did indeed pass. Okay. So now we can add a bunch of inline data that will help us test those message box errors as well. And so again, I'm going to fast forward this so that you don't have to sit and watch the whole thing. All right, so we're back. Let's go ahead and take a look at our test now. So I tried to track down all of the different places that the message box was being called in those if statements. And I believe I covered all of them, so let's go ahead and take a look at that. So let's take a look at our code coverage, because that's going to be what's going to tell us whether or not we've tested everything that we should have, at least for this particular first iteration. We look at our calculate method. It looks like all of that's blue. Okay, perfect. All right, so now one of the things that the original author did do is they did do some error trapping. Obviously, this is a first iteration, first refactoring to make it testable, so we don't want to change it too much. So depending on what your particular project's exception catching methodology is, you want to stay consistent with that while you create your tests. So he's got a format exception in here. And if we go and we look, I believe, let's get rid of our code coverage highlighting here. Yeah, so we're converting some text, some strings into numeric formats. And so my guess is that if you were to put something weird in there that's not a number, you'll get a format exception. So let's go ahead and run the application and test that. We should be seeing this particular error message if I'm correct. So if I put in ABC in for one of these here, yep, that looks like the right error message. So it looks like we're probably going to be able to get in there if we put in ABC for the number of disks. And so let's go ahead and make a test that does that. So we're going to go ahead and use our bad data test, and we're going to say ABC here. And then I think what I had done, and it shouldn't matter, but I think what I had done is ran this test, and you always want to make sure that you're running the same test manually as you are coding for. So let's go ahead and run this and make sure it passes. Okay, perfect. So all the tests are passing. And if we go look at code coverage again, okay, our calculate method, we should now see blue code in the format exception. Perfect. Okay, so overflow exception, we should get an error that starts with overflow in English, or it's the same in English as this other language. And so what I want to do is run a test. If I put in, I'm trying to think, so if disk count is being cast to an integer, we need a really big integer to overflow an integer. So let's do RAID 0 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 digits, all nines. Okay, there we go. So 12 nines is going to give us the overflow. And I think we will have hit that use case then as well. So let's go ahead and make a test for that. And so along with our ABC, okay. All right, so we can run that test. And we can confirm that it did indeed pass. All right, so we're getting really, really close if we go and we look at our code coverage here. Now, the one test that's going to be really hard to do, I was trying to come up with some way that we could make just a general exception throw given some sort of input into this method. I'm not sure we're going to be able to cover this particular block of code, which is really disappointing to me. However, what I would probably do in this case, since it's not something that can be covered, I would probably grab this and cut it out of here and maybe throw the general exception testing over here into, or not the exception testing, but the exception catching over here into the window itself, put it back where it was originally. And so I think that is going to probably be how we achieve our 100% tested code there. If you can think of a way to make a general exception show up, by all means, let me know in the comments. Otherwise, I think if we go ahead and run all the tests, let's make sure we're all green lights here. All right, perfect. And then if we go look at our code coverage one more time, go into our class, take a look at our calculate method, we should see all blue. And we do. So now this is 100% tested as far as code coverage goes. There are some, now the other thing to think about is there are some edge cases. We're probably going to want to handle some edge cases. We did an overflow exception and that sort of thing, but there's some weird things that can happen. For instance, if you put in negative numbers, then you may end up with some funny results. I don't know how you would have a negative number of disks or a negative number of terabytes, but um, you can end up with negative total storage in that particular case. So there's some edge cases that you may want to throw in there. In this particular case, it doesn't look like it's probably going to change the way that we test it in our unit test, and so we're not getting any sort of different behavior. It's still doing the math the same. However, it's just kind of a weird use case. So maybe that's something we handle with validators in the future. We log that as a bug or something like that. So in any case, I believe we've accomplished our first goal. If we go look at what our goals were, the very first goal was to make it testable. And that's what we've done. We've created a suite of unit tests that go ahead, then they cover our code completely. And now we can start refactoring, adding features, and changing the application so that we know that we didn't break anything. That's all for this one. If you have any questions, let me know. And I will see you in the next one when we talk about localization of a WPF application. Thanks.